Hello, everybody. Thank you for joining us over lunchtime today for our soil webinar, Finding Common Ground by Perth NRM and RegenWA. This event is supported by the Department of Water and Environmental Regulation through its SoilsWest program. My name is Bonnie Jupp and I'm the RegenWA Program Manager here at Perth NRM. And before we begin, I would like to acknowledge the traditional custodians of the lands we're all zooming in from today and pay our respects to the cultural elders of the past, present and emerging, and acknowledge their spiritual connection to country. So we're very pleased to have Fran Hoyle from SoilsWest and Sarah Fea from Soils for Life joining us today. So Fran will provide an overview of SoilsWest, their current projects, including a large nutrition project happening here in WA, give an insight into some useful resources that SoilsWest have, and I guess there's a World Soil Day coming up. So I guess just a bit of what's happening in SoilsWest's world. And then we'll jump to Sarah, who will then give an overview of Soils for Life, and then dive into how to restore soil functionality by unpacking the soil health principles and monitoring tools that she's currently using in the field. So if you have any questions throughout today's webinar, please pop them in the Q&A box down the bottom. So we use that specifically for questions. And because this is a webinar, you can't like jump on and ask the question. So we use that Q&A function and then I'll call out the questions to the speakers. And another thing before we begin, some of you may be jumping across to the WA Landcare network checks in that's happening directly after this one, where Lynn Abbott is talking about the soil health app. So if you have already registered for that one and are jumping across, then we'll make sure we'll finish up on time so that one can get started. But if you haven't heard about it and want to head across, what we'll do is we'll pop the Zoom link in the chat so you can click that. They're happy for you to just jump onto that one if you've blocked out the time and want to keep having soil conversations. I think it's they complement each other well. So yeah, would encourage you to jump onto that one after if you've got the time. So with all of that, I will just now give an introduction to our first speaker, Fran Hoyle. So Fran is an associate professor in soil science and industry engagement and a director of SoilsWest at Murdoch University, and has a PhD in soil biology and masters in agriculture. Is that right, Fran? Yep.
Correct.
So Fran has a clear focus on communicating science and has worked to actively contribute to the development of RD&E priorities for the grains industry more broadly in soil science through a variety of mediums. Fran has 30 years research leadership in soil quality, integrated soil management, soil biology, and organic carbon to support resilient and profitable dryland farming systems, including national, state, and regional investments. Fran has science and broader publications on managing soil organic carbon, microbial processes, carbon cycling, benchmarking and modelling of soil organic carbon in WA. Please take it away, Fran.
Great, thanks, Bonnie. And just to begin, I'd like to also acknowledge the traditional custodians of our lands from which we come and their enduring culture and custodianship of those lands, as well as their current and emerging and past leaders. So I'm just going to share my screen and tell you a little bit about SoilsWest. So hopefully that's showing up okay for you there on the screen. Great. So essentially we are an alliance that was formed recognising that all of the soil scientists that exist in Western Australia quite often work independently of each other. So this was an alliance formed initially between the Department of Primary Industries and Regional Development and the University of Western Australia to increase connectivity between the scientists and then between the scientists and the industry, and going forward between scientists, industry and landholders. So it's about ensuring and encouraging collaboration, ensuring the best investments have the best teams targeting challenges in soil science, and making sure that we are attracting students into the universities to learn about soil science and to be our future soil scientists going forward. So it's really critical in thinking about soil scientists who's taking over next? You know, Bonnie's mentioned I've been here for 30 years and I feel like I've been here for 30 years. I love it. But I want to know, you know, who is coming up and who's going to take on that leadership going forward. So I will try and move the screen, but it's not moving. Oh, there we go. So we established in 2016, as I said, with DPERD and UWA. We started publishing our soil quality ebooks, which I'll talk about a bit later, because they are essentially the tool which brings together all the science knowledge that we currently hold in Western Australia among our soil scientists across the organisations that are research delivery agents, but also our industry experiences and our grower experiences. So talking about how they've walked through the experience of managing soils. We started collaborating with Murdoch, and last year we actually moved our head office from UWA to Murdoch University, and we had our co-director appointed. So we work really closely with the Department of Primary Industries and Regional Development, and Chris Gazy is our other co-director of SoilsWest. And we also managed to appoint a science communication coordinator. So you might notice that we have a SoilsWest Twitter handle. That is where we encourage people to join in and learn about what we're doing in both in terms of science, but also in terms of events that we're running, and who we're working with and what we know about the science that's happening on ground. Adding to that, we've then got alliances strengthening with organisations such as the Grow Group Alliance. So we have the appointment of the Southwest WA Regional Soil Coordinator, and they're working with the Smart Farm Small Grants grantees to say what's happening in soil science across WA, and then bringing that into the national forum. So it's about bringing together the regional, the state and the national soils interests. And going forward, we obviously like to grow our alliance, lots of things that we do in terms of events, workshops, pulling together alliances of partners to bring in new projects and develop new ideas. So it's really about extending and translating the science that we discover into messages that are useful on ground. Just a few examples of those going forward. So this is, it's a very busy slide, I can tell, but for example, GRDC invested in a major soil nutrition project several years ago, 3 or 4 years ago. That's led by Craig Scanlon out of the Department of Primary Industries and Regional Development. And that includes organisations that came together to invest in what was overall, with all the partners, almost a $15 million investment. And that includes DPERD, CSIRO, UWA, Murdoch and Curtin University. So you can see that it's advantageous in terms of bringing together the right capacity from different organisations to target solutions for particular challenges. And in the particular case of this project, it's around nitrogen, phosphorus and potassium. And we're not only thinking about fertiliser management and agronomic management, but also about the soil supply of those nutrients. So doing part of the work that looks at how nitrogen cycles through soils, when it's available in relation to when a plant needs it. So how do we better utilise our resource, but still maintain that resource health so that we can continue to farm those soils going forward and secure our food for growing populations. We have a major project, again, funded by GRDC around gravel soils. So gravel soils has been one of the really interesting projects the last 2 years. Traditionally, you send a soil sample into a lab, it gets sieved over a 2mm sieve and all the gravel comes out and nobody thinks about it any longer. What's been really interesting about this project is the discovery that there are lots of types of gravel that are quite different. And depending on their makeup, they actually have a significant potential to tie up nutrients like phosphorus, for example. But that also, some of them are quite porous. So you think of stones being something that doesn't hold water and doesn't hold nutrients, but in fact, it can actually hold a significant supply of both water and nitrogen, and release that to the plants when it's available. So we're trying to understand how we manage those gravel soils in the context of fertiliser and agronomic management. So that's in phase 2, and we're going forward with that. We've had GRDC invest in the soil quality ebooks. There's currently 8 published, and as I've said, they're really a compendium of all of our current science knowledge in an easy to read format. They're free to download. They're available only on the Apple platforms at this point in time, but we are developing up website content that will reflect some of that interactive material. But we do have a range of them, from integrated soil management through to constraints to plant production, through to a book on organic matter in soils, soil biology, soil compaction. So we're looking at both the health and the constraints that are present in soils with that publication series. So I really encourage everybody to go and download them. They're a great resource. They're very interactive. So you have animations, you have people talking in soil pits, and then having that related to the data that's available with it. It's very good in terms of learning and teaching. And then I've mentioned Jenny Clausen, who is our regional soil coordinator through the SoilsWest WA Drought Hub. You know, she is now working with a lot of the grower groups in terms of understanding what their needs are for soil science. And that's really important to us in the science fraternity going forward, because quite often we come out and talk about what we love and what excites us. And sometimes we don't always talk about what you want to hear. So I guess this is a strategy where, you know, the Grower Group Alliance and the Drought Hubs are trying to encourage a gathering of knowledge about what it is that you need to hear or need to know, and how you would like that information delivered to you. So hopefully you'll get on board with that. We'll be able to provide you with better products and better information flows that will help with your decision making. I said we have a new science communication coordinator. So Ryan Brett sits in Murdoch University as our new science communications coordinator, very friendly, very open. He's the one that's responsible for doing lots of the newsletter stories that will be coming forward. So we'll be profiling lots of the science work and the scientists that are coming forward over the next 12 months. We've got lots of other things up there that you can see. We have a couple of new investments. So we have a new project looking at the role of soil fauna in agricultural dryland systems for Western Australia that will start next year. And we have both a postdoctorate position and a PhD associated with that. And we are also involved with a national program led by Mark Farrell out of CSIRO in Adelaide, where 12 years ago, we sampled 1,000 sites across Western Australia and determined the soil carbon stocks to 30 centimetres depth. And we'll be going out to revisit a small number of those, only 75 sites this time round. But the intent is to give us some indication of whether we can use the paddock management history, the climate, and the agronomic management from those growers to say, how did carbon change over the last decade? And is there particular strategies that we can associate with those, with that increase or that change in carbon? So we're looking at grain systems as well as perennial pastures, as well as dairy systems in this instance. So we'll get some information, and hopefully that will step us forward and point us in the right direction as to how we go forward with, you know, our strategies to build soil health, and where it's possible to build carbon. And you can see there's a number of other different projects there. The ebooks I've talked about before, there's a nice pictorial of them. The QR code, if this is recorded, you can just scan. It will take you right to the direct link that you can download them at. Once they're downloaded on your device, they don't need a network. So that's really attractive in terms of if you're in a tractor and you're wanting some reading material as you're harvesting, gives you a great resource to go to. And we've had over 8,000 downloads of those books, and they are being used in the undergraduate teaching area as well. So our students coming through the university sector get really good experience and exposure to the network of scientists, industry and growers that are present in the books as they step into the industry, which is really a step ahead of where we used to be. So that's great. I thought I would put up the soil quality website because it's quite old website now. It's probably about 20 years ago that Daniel Murphy and myself went through, and we workshopped with industry and growers about 40 different soil quality parameters that we might use to indicate how we considered a soil was performing or functioning, and whether it was healthy or not. And we came up with a traffic light system that indicated, you know, green is good, yellow, be aware, you know, you might have to take some steps. Red is, you know, you're in it. That property has some limitations in terms of being able to support plant growth. So you can see in this slide, for instance, that photo shows a soil pit where we have 3 constraints all present at the same time. And that's quite common across Western Australia. We have, in this case, a non-wetting surface, so that rain, when it falls, is not coming into the soil. So that starts to slow down biological activity straight away. We also have subsoil acidity. So you can see as it gets deeper, we're getting more acid. So again, roots are constrained, biological turnover of carbon is constrained. So the function of that soil is constrained. And then we also have a compaction layer. So how do you step through these strategies where you address the significant constraint first and then move on to start building and creating that really healthy soil, which is what you want as an outcome? So we can talk more about that later, but I know that Sarah is going to touch on soil quality, so I'll leave that really quickly. And just talk a little bit about, just give you some examples. So this is our Twitter account. It talks about our research. So I talked about Francesca, who's in the middle. She runs the Gravel Soils program, and how that phase of that work is going to end up with better decision making and better tools for growers to say, if I have gravels in my soil, what sort of gravel is it? And depending on what sort of gravel it is, how do I then manage that soil more appropriately? So that's going to be a really significant piece of work over the next couple of years. We've also got an example of Louise Barton at the University of Western Australia, who is leading a program around nitrogen losses in Australian cropping systems, and in her case, in the West Australian environment. So how do we enhance our knowledge to better predict nitrogen cycling and how we use it? And where are we seeing the most losses? Is it ammonium volatilisation? Is it leaching? Where do we learn? And then we've got things where on the right-hand side, we've got our team sampling, and we use, in this case, a labelled fertiliser to track how the plants use the fertiliser versus how the plants are using the soil nitrogen supply. So that is going to tell us about how we time our fertiliser strategies better. We have lots of networking. I've mentioned before, we generally, we had a workshop that, again, Louise Barton led the Organisation for Soil Science Australia, working on water repellent soils. We've also had one on organic matter and biology in soils and functioning, as well as soil acidity. So we are getting people together to discuss our major constraints and how we address those. We have the launches of our soil quality books. We are trying to make sure that we keep in touch with the National Soil Advocate. So the National Soils Science arena is aware of what our problems are. And we have the seminar series, which is every month, that you are more than welcome to join online. Our capacity, so I've talked lots about students, it's getting harder and more challenging to attract students into agriculture and particularly into soil science. So, we have a number of master's students at the moment and PhD students, and I'm showing you an example on the left. This is Sean, one of our current master's students, who's actually got an internship with Food and Agriculture Organisation, so FAO, which is a global organisation, and looking at soil carbon stocks across Southeast Asia. So it isn't just about Australia, it's what we can learn globally and it's what we can teach globally. So how do we make those links and how do we support that new capacity to be able to carry that on? So this is just an example. DPERD has a significant, and GRDC have a significant investment in re-engineering soils at the moment. We have the students, so part of the questions that we ask, how are soil carbon stocks affected by soil amelioration? When we plough them up, moldboard them, spade them, do we accelerate loss? Do we increase the capacity to store new carbon? Do we, by growing deeper roots, get deeper carbon? And they're all questions that we don't yet know the answers to. So new science is needed to understand all those mechanisms. What happens when we add amendments? How does the persistence of carbon change over time? Is it stable or is it labile and it's subject to loss? And are we linking that with soil function? And, we're looking there to re-engineer soils to double our yields, essentially, at some of these sites. We're looking to say, how do we do this sustainably, provide more food, but keep a really healthy resource in our soils, not use that bank, just recreate that bank and keep it healthy and keep it sustainable. Again, new monitoring tools. This one is around crop nutrition. And we have a student looking at, can they develop a nitrate sensor to measure nitrate in soils? And that was my signal to shush now. So I'll just finish up. We've got a couple of projects with WARC. We're really interested in soil biology, carbon and nutrition. That's our main core of focus for research projects at the moment. But we are interested in the rapid real-time sensing for decision making. And just the last one I'll finish on is quite a new area for us, is around bioplastics and biopolymers. And in this instance, for example, we have a new place at Rockingham. So Murdoch has a campus at Rockingham, and we are looking to see whether we can use polymers, for example, as a coating for soils to funnel water, whether we can use them to deliver microbes to roots and soil root engineer, rhizosphere engineer. And what's the capacity in some more new novel science. So that's not necessarily going to lead to an outcome for growth straight away, but it's certainly part of what is the basis of what leads to those decisions and management strategies going forward. And I'll leave it there. Thanks, Bonnie.
Thanks so much, Fran. That was great. And there's so much work going on, like on ground, but it's interesting that you're developing that platform to share that knowledge and, to get that information to the growers, like what information they want through your Twitter and events, and linking the science to the farmers through that communication. And the other thing as well, it's like it sounds like there's lots of really good opportunities for students as well coming in to get involved. And so very exciting stuff happening. And thank you so much for sharing that with us. If I don't see any questions in the Q&A, but if you did have a question for Fran, pop it in the Q&A and we'll have some more time at the end. So if you did think of something as we go, just pop it in that chat box there. So I'll now introduce our next speaker, Sarah Fea, from Soils for Life. So Sarah believes that agriculture is a noble practice and forms the health of civilization. Her passion is building the capacity of our agricultural communities from the ground up by reconnecting us to our roles as food and fibre producers. No matter the enterprise, location, or choice of management practice, Sarah believes the one conversation that unites us is achieving restoration of soil functionality. And as an agroecologist with over 30 years of experience in nearly every agricultural space, Sarah supports individual farmers and small groups to transition their management mindsets and practices towards improved soil and landscape health, supported with in-field observation and fit-for-purpose lab tests. Her purpose, her why, is to help farmers gain better understanding as to how to appreciate and manage freely available resources: soil, water, sunshine, air, and soil micro workforce, human community to enable their most effective functionality. All right, with that, I'll now hand it over to Sarah.
Cool, thanks Bonnie. I'll just share my screen. Your technology is going to play. Thank you, Fran, for that wonderful overview of all that you're involved in. To cover the topics today, just a quick overview for Soils for Life. So I'm only recently joined Soils for Life around May, June this year as their agroecologist, and really loving the experience. And so originally, for those that don't know much about Soils for Life, was founded nearly about 10 years ago now by Michael Jeffries, known both as the Major General and Australia Governor General. He had a passion for people understanding the value of soil health, and he felt it was essential for Australians' future. So he was the first Australian soil advocate, and he really helped elevate a conversation for us all. So today we're continuing that work. It's nearly 10 years now of collecting and telling the stories through case study format of farmers all across Australia who are stewarding their soils, as well as we lead peer-to-peer learning groups of farmers, focusing on the conversation around soil health. Some also other great projects that I'm getting to be involved in is the National Soil Extension program. So like Fran was explaining, making sure that we're funneling in what we're hearing from farmers on the ground of what their needs are and what they're curious about and what they want to know more information about, and disseminating that throughout our communities. But another one I'm really excited about being part of is also putting the conversation of soil health into our national high school soil syllabus in a partnership with Prime Ministry Education Foundation. So I think that's fantastic that we can actually put cutting edge new understandings that we've got in soil health right there into the syllabus for our schools from year 7 and up. So I think that's pretty exciting. That hopefully that might lead into you seeing some more at your door, Fran, as well, for people that might get hooked by soil health like we are. So if you're curious to learn more about what Soils for Life is doing, please check out our website, newsletter, and lots of social media. We're on Facebook as well as Instagram. We're also, the current case studies that we're working on is actually cropping case studies. And I recently was actually just over in Western Australia to work on one of those with Rob Hetherington down the south there. So, and touched in at the Haggertys as well, which was exciting. So yes, have been over your way. I'm talking to you from the Darling Downs in Queensland. So I'm just a few kilometres away. But we actually have sunshine today, so that's fantastic. So is my screen going to work? Yes, so it's onto that one. But to deep dive into what we wanted to cover today and help you all start, expand your journey on thinking about soil health and soil functionality. I wanted to pop this one up, and Fran, you actually made mention of, the Food and Agricultural Organisation with one of your students there, but I think this is a fantastic informatic that really shows us just how much the soil function, in terms of as distinct from soil functionality, but the function that it actually has in our society, and how it is very important for us, not only on our farms, but in any part of our life, in any part of our society life, that we work to try and help people understand the importance of managing their soils, whether it's in their backyard or in the town community, because it is so foundational to the health of the ecosystems that we're trying to all live. So I thought it was just a great because I mean, cultural heritage, how many of us actually think necessarily of the wealth of knowledge that we've learnt because those artifacts were stored and preserved in the soil for us to uncover. So I just thought that I'll put that for an exciting aside to keep trying to entice you all to the wonders of soil that people like Fran and I are very passionate about. So I thought it was interesting, Fran, you touched on soil quality, and I guess for today I wanted to help people have maybe the appreciation of the little distinction between perhaps soil quality and soil health, in how we look at these things, in the sense that perhaps, to not put the negative or positive, there's no such thing necessarily as bad soil, but do we actually understand it? Have we got the capacity with the knowledge that we gain from exploring it, how we can actually better manage that soil and help it function to its full potential? So, lots of the quality traits come from its parent material and the componentry of sand, silt and clay that might go towards that soil and how it's built and how it might form in the landscape and the layers and whatnot that we might need to deal with once we observe them and explore them and try to unpack them and gain knowledge on them. But it's another thing to actually give support that soil's ability to actually achieve good health and functionality. So, and that's where we bring in, our understandings of learning what is going on from the chemistry perspective, the biological perspective, and then the physical as well. And, and the wonderful thing that, plants make soil really drive the health of the system, and therefore give us in turn the organic matter that makes some magic happen between the chemistry, the biology, and the physical. So, and a lot of what often we're talking about, and we might talk about it from a carbon sequestration point of view or that, but we're actually, driving that process of photosynthesis through the biologies, getting the most out of those soils, feeding those soils, and in turn building organic matter, and therefore the cycle, goes again. So a bit like the soils, no matter what plant might show up, it's giving us the ability to support that soil to step into its function, keep life going, bring more moisture in, and the cycle continues. So, we pose that question, what is a healthy soil? And then really it depends. So a lot of that comes back to the management decisions that we make from the observations that we take as well. So I guess this leads me to one of my passionate ways that I want to share, really having us all connect that, what happens in the soil does affect the health of our animals, our plants, and ourselves. It's all interconnected. So to make it quite simple way to really connect with that soil is a living entity, a living, breathing entity with lots of different organisms down there that we're still exploring and finding exciting more information about all the time, is that they are in the food web of life like we are, and what they need to sustain is just the same as us. So when you make a decision about a management action, if you can reflect upon these 7 principles that unify us all, then it helps you make more robust decisions. Is this action going to affect these components? So I guess, you can all see them there on the screen, but to identify more deeply with some of them, say, for instance, air, we might consider how to explore air by just simply digging a shovelful of soil. This is some of the monitoring we can do, and look at the structure and the crumble structure there, and whether we actually see physically a compaction layer there, whether the roots are going in funny angles, whether they're not going very far down at all, or whether they're beautifully going to depth. We can test that also with our penetrometer. Another way we could get some understanding about what the aeration capabilities of that soil might be is on a soil test, we would maybe look at our calcium to magnesium ratio, and that would give us some understanding of the struggle in terms of tightness that might be going on in those soils. And I've got soils over here that can be 1-to-1, so it can be quite tight as a clay. And the exciting understanding that we have now that, a lot of these processes of nutrient delivery is actually mediated by the microbes. Up to 90% is quoted by Chris Nichols. So when we have been taught often, it was mass flow or interception that nutrition was coming into the plants, we now know that we've actually got this amazing community there that we need to support and enable them to rally to support us delivering nutrition to our plants. So they also need these same principles, to encourage their ability to maximize their capacity to function. But it opens the exciting opportunity to understand that when we've got low water situations, our fungi and our organisms can actually operate at lower levels than our plants often can. And therefore there can be still delivery going on because the microbes are literally through rhizophagy going into the tips of the roots, being consumed by the plants and releasing the nutrition to the plants. So it gives us an exciting new way to look at things in our low water environment here in Australia, to how do we support this biological workforce and how do we enroll them more effectively. And to quickly go through the rest of the list, sunshine is the driver of all through photosynthesis. And even ourselves as humans, we know how much more we are energized if we have some time in the sun, as do, we need the efficiency of that system for the plant soil microbe relationship. for the plant, releasing the exudates to the microbes, feeding the soil and giving it the capacity through the biology to support more nutrient delivery back to the plants. Exercise, this is a fun one because it makes a lot of sense from a human perspective, but I guess, you know, with cracking clays and pore spaces that are evolved through, say, worms coming in and that sort of stuff, that's where I think about it. Like, we've got beautiful cracking clays over here. And I do believe in some areas of Western Australia as well. So that's that sort of the exercise, the natural exercise of the clays, bringing in air and water functionality. And relationship and community is easy to consider with the microbes, lifting the diversity of that community. How can we support that? Getting more people, more microbes, more organisms, more plants into the diversity to build relationship and build functionality. And the passion, again, human, easy to understand. Animals we observe. For here, I've taken the liberty of, like, it's passing the ions on. So that's from a chemistry point of view, the delivery of nutrition from an energy perspective of flow. And then for us, it's the passing information on, which is what we're doing today. That, connectiveness, and then the whole foods, I guess, is that really important concept of, it's not just quantity, but it's quality. And a lot of our soils are actually starving. The microherd is actually starving, and that's an important reason for what we need more flow of, plant exudates and things into the soil. We need to keep plants in the system for as long as possible, as many days of the year as possible. How do we change up our rotation? How do we manage with that in mind to flow right from the smallest of organisms needs in terms of food right through to providing ourselves up the chain nice, nutrient dense, healthy food. So to dive into some of the monitoring, and I sort of alluded to a little bit there, some of the things that I do in the field, either with individual farmers, with our groups, is to equip them with some simple tools that they themselves can do, or then help them understand what different soil tests are available, what they mean, and what to actually ask there as well, because the soil test isn't a soil test. It's important to actually ask for the right components so that you actually have enough information to make decisions with. And I guess I'm really encourage you to establish or create a very curious mind. What am I looking at? What really is going on here? Is my first assumption really correct, or is there something more going on? Really start observing your landscape. Become, as Charles Massey would talk, get landscape literacy into your life. And an easy way to start looking at for soil and plant, because I guess it all does go together. And a lot of what plants are growing above the soil surface are teaching you a lot about what is going on underground as well. And that is something that we can calibrate, something you can learn. There's lots being written about this in literature, but it's also something for yourself to observe. Well, I'm seeing this plant here and I did that last season. Has that led to that? So it's sort of trying to calibrate what is it that I'm seeing. And a great way to be able to see the transition over time is to establish either a transact or an area that you can easily return to that you're observing these things over. And of course, that's different whether it's a grazing setup or cropping, perhaps how you might go about that. But, I think it's an important exercise to do so that you can actually, and taking pictures is a fantastic thing to do, because phones these days, they trap time, everything, it's all there. So when it's downloaded in your computer, you've got that data to easily compare what happened last season to this season and do some processing on that. And simple tools to empower you, just go out in the paddock with your shovel, have a look, what is happening, as I was saying before, what's happening with the roots in the system. Do we have capping you know, what's going on? What does it smell like? You know, and if you don't smell anything, well, that's not, you know, we want to actually smell, you'll have that earthy smell. What's happening with the plants? Can you actually see dreadlocks or rhizome sheaths forming, and knowing that there's biological magic going on in there? Nodules, known for nitrogen fixing, but perhaps we need to pose more questions. What else goes on in there as well? And what directions might these roots go in? Because that then gives you indications of whether you've got either compaction issues or you've got other chemical or pH things going on that you need to observe. And penetrometer is another simple tool. You can either have one that's got the gauge on there that helps you know that you're having to put increased pressure on to actually get through. So there's, you know, then that the plants are struggling or might struggle to get through there, or you can actually make your own rod and self-calibrate there. A Brix meter, which is known as a refractometer as well, is another great tool that you can buy to measure it's basically the total dissolved solids that are flowing through the veins of your plants. So it's a quick, easy indicator of how healthy, how efficient is photosynthesis occurring right now in my plants. And, you know, are they actually healthy enough? Do I need to step in and do something? How are the other plants actually looking? And in turn, another meter that I love to have on hand right at the same time and teach people to use when you're getting sap out for a Brix meter is a sap pH meter. And that actually can tell us a lot about whether with different nutrients, depending on whether it's alkaline or acidic, and whether we actually might be looking at an insect problem or a disease problem. So it's a great decision-making tool to help you give the heads up, right, I need to make more observations here, and I might need to put a foliar on or something like that to support these plants to have healthier function, which then it drives the soil, and we can actually use those results to help determine management moving forward for the next season as well. You take that data, any piece of data, bring that in and help formulate your decisions on how your soils are tracking, what maybe we need to do for the next season. And of course, water infiltration tests, very important. It's, you know, bragging rights of how much rain's in the gauge is not really very helpful. We actually need to be able to say that we've actually had great water use efficiency and infiltration, and it's actually in our reservoir, ready, waiting for the plants to utilise. So I guess to wrap this all together, we're making good health, you know, soil health decisions. It's really important to understand your soils context, as in where they're at through those observations, and then your own context. What is your expectations? What do you need of that paddock or that situation? What is your rotational plan moving forward? Is it suitable? Do you need to readdress that? Are you actually expecting the right things of your soil right now and the health that it's at? So, you know, it is a living system. Let's, you know, measure that. Let's get some data, either yourself or through the lab. We can do soil food web analyses as well to really know who we've got there potentially to step into this fantastic support role with 90% improvement in soil functionality that can be achieved thanks to the microherd. I mean, we actually know that the micro aggregates and the macro, so the micro aggregates are likely to be formed thanks to a highly bacterial soil, and the macro aggregates are more formed through your fungi communities and things like that. So they're actually very important in terms of creating your structure as well. So, and then there's a myriad of tests that you can get to analyze what actual nutrients and components, you know, from, dare I say, the periodic table that are there in your soil. And I advise to get not only what's available in soil solution, but also what's in the total long-term pool, which is something that through right management and support of the microherb, we can actually get access to in a reasonable timeline through good management. So it gives you an appreciation of the different pools that are flowing into the system, and with nitrogen being a classic one of those, that we've got multiple pools that are all biologically mediated, that through good management decisions, you can actually be supporting that cycle and literally have free living nitrogen fixers in the soil, pulling from that great big 75,000 kilos per hectare reservoir straight into your system. So one thing to have these minerals there, but are they functional? Are the plants being able to access them? So that's where we can then test again, do plant tissue testing either through the laboratory or utilising initially those Brix meter and the SAP pH meters, which there's quite a myriad of those, a lot more than just SAP pH. There's nitrogen, calcium, and all those sorts of things. And then I guess really critical to think any decision that I'm making in my management, how is this affecting the soil matrix and the health and functionality of our soil? So it's key for us to reduce the physical disturbance of that system, and any action that we take is potentially a disturbance. Any input that we put in the system also can have an impact on the biological community. And I'm not saying that's necessarily negative or a positive. There just is a response to that biological community, because anything that we put into the system, they do see as a potential food source, because everything that we have at our fingertips comes from that one periodic table. Everything is either a different combination of that one periodic table in life. And so therefore organisms either are part of putting that together or pulling them apart, which I actually think is pretty cool. So, and then that leads to, any opportunity you can, diversity, whether it's diversity of plants or how am I supporting diversity in the organisms in our soil, which leads to therefore up the food web of life, our plants and our animals and ourselves, having an increased diversity in not only biological community that flows with those resources as we consume them, but also in nutrient integrity and density. So that's me, the things to ponder and what I work through with my producers.
Thanks so much, Sarah. That was great. It was really good to have that reminder just to go out there and see what's going on with our soils for that observation. And I like the idea, obviously, to have those transects and just monitor over the years, take lots of photos and just be aware of what's happening and get the trends of each year with the seasons, what's going on in our soils. So thanks for that. So I guess we can continue that discussion on how we measure those soil health indicators, because we've got one question just come through from Mick from Binjarab country. So a question which I think Fran is typing an answer to as well, but I guess, I reckon you can both have an answer for this. What advice do you have for farmers who want to transition away from using traditional fertilizers towards building their soil health by using organic based products, particularly in a forecast drying climate? Did you have any comments initially, Sarah?
That's quite a big question. There is lots of opportunities for transitioning, and I guess that's something I do support a lot of farmers in doing. And I guess it does depend on your location perhaps as to what you might have available to you to actually consider, or whether you're curious about what ones you can actually create for yourself. But I guess it is make sure you start off well by assessing where you're at, where your system's health is at, where the functionality is at. with those observations and tests that I suggested. And then it's understanding that when we're supporting the biology to be part, come back into the delivery system there, we've then got that whole extra area of access of nutrition that before we were cutting off with synthetic fertilizer. So we now not only have mass flow interception, but we also have delivery literally by microbes and full amino acids and whatnot. So you do have to think about ensuring you don't have too much synthetic in the system that actually stops the plant and the microbe making a relationship to actually decide that for the plant to actually, I know this is making it very human sounding, but for the plant to actually go, yes, I'm going to need you to help deliver me all these nutrients because there isn't at this time enough in soil solution, but we know that we have got these long-term organic pools that the biology is going to be able to access this nutrition from, and then also through increasing that engine capacity, accessing from the total pools as well. So I hope that helps to a point, Nick.
So I might just jump in there if I can. I've just typed a really quick reply, but there's quite a few things that I guess you need to consider. There is, we've got a really good understanding of nutrient cycling in soils and when that happens. And so, for instance, if you think about, Mick, you mentioned a drying climate, there's also scenarios where they're saying, well, yes, drying in winter and then perhaps increasing rainfall and frequency in summer. That's going to be really critical because what that does is in summer, with each 10-degree increase in temperature, your microbial activity doubles. So if it's wet and moist and there's carbon there and it's hot, it's going to be turning over really, really quickly, which means that you need to start thinking about a strategy where you can either capture it in another plant if you've got an ability to have a cover crop or something like that, or you've got this store of nitrogen right at the break of season. So then you start to think about how you might change your fertilizer strategy where you are more or less confident. So if you're really confident you'll have lots at the beginning of the year, then you might just give it starter nitrogen and then just top it up as you visually check in on your plant health through the season. The other thing, so there's the soil side. The other thing I'd say about the organic fertilizer side is that with the research done over the last 20 years, they've included things like biochars. So there was a project led out of CSIRO where they tested about 70 different biochars, and they're quite unique in their characteristics. They can have really low pHs or pHs that are up near 12. They can be quite nutritive or quite poor in nutrients. So it's really important with anything, doesn't matter what the product is or what the amendment is, that you understand its characteristics. Because if you understand its makeup, we know enough of the science to be able to tell you when it should be releasing nutrients and when it might immobilize or tie up nutrients, and how that might fit into your system. So generally it's a, gently a little bit, I guess. But we do know lots about the science. What we know less about is the ability, and we're not farming. So, it's much more different when you have to carry cash flows and you need, some money sort of to get through the next year. So it's really dependent on a person by person basis. The other thing that Sarah also mentioned is be really aware of what your soils are in terms of, their quality, their health. If there is a major constraint such as subsoil acidity, then you might want to just say, well, I have to step in and consider a liming strategy before I get to do the final level of management. So there's lots of different information that could inform you. There's lots out there. There's lots of people, as Sarah's mentioned, that can help you with that transition. But it's an independent journey because every farm is different.
Thanks so much, Fran.
I hope that helped.
Yep, Mick says thanks. I guess we have another question from Aaron, which I think is quite similar to that previous question, because it was saying how can farming operations get involved or be supported, or I guess by SoilsWest and Soils for Life on the transition of sort of more conventional methods and inputs to regenerative practices, which I guess one part of that would be maybe reducing those synthetic inputs, but obviously understanding the soils and just getting guided along that transition. Yeah, does anyone have any comments on what projects they could get involved in? Or
I would say reach out, like, you know, actually we do have on the website where you can actually, you know, reach out to us and say, you know, exactly what you're looking for. And there might be a peer-to-peer group that we've already got established that might be able to support you, and that will have farmers sort of in various regions throughout Australia that then can bring you different contexts and different angles to help, you know, richly support you there. Yeah.
And again, just jumping in, I guess, if I take SoilsWest, you know, we started off as an alliance for soil scientists, and we've sort of jumped in and said, well, let's get better aligned with some of the grow groups and the NRM groups and the industry. And we will be taking a step forward to get better aligned with growers. But what I'd certainly say is, you know, with the Southwest WA Drought Hub Regional Soil Coordinator, it's a big mouthful, you know, they're looking to say, so what one of their roles will be is to make sure that we've got a map, if you like, of who are the people that could help you analyze something or interpret something or have some knowledge in different areas. So we're going to have like a knowledge bank, I guess, if you like. And the intent is that we will also, over the next 12 months, put up a knowledge bank around soils, which is more generic, but we'll have enough in it that has some case studies that might transition somebody through. But, you know, I guess we probably aren't as well placed as someone like Sarah in terms of helping you step through those. We are concentrating on science and translation of the science, but certainly reach out to the Grow Group Alliance groups, the NRM groups. They all have fantastic contacts, and, you know, this area of interest is just growing. So my feeling is that there'll be more and more information generated, and I think it's really important to step through this with some level of confidence, and make sure that we gather evidence as we're growing our knowledge and our experience as well.
Yeah, and I guess I add, that there's that bank of 10 years of case studies that have really followed people's journey through regeneration, you know, and regenerative practice there for you to go and check out, Aaron. As well as, I guess, there's even communities online that you might look to join. So I think, because whenever you're trying to tackle something new, it's very important to actually find some like-minded people and get them on board to support you, so that you hold strong to what it is that you'd like to do.
And sometimes the process of stepping through is different for different growers as well. So sometimes they like to experiment with a paddock rather than a whole farm, or, you know, there's a particularly degraded area that they want to sort of refocus on and get that back to health. So I guess it depends on what perspective you come from, how you might step through that journey. But as Sarah's mentioned, there's lots of resources out there.
Yeah. And I guess both organisations have a lot of online resources already. So the ebooks and the case studies, that's a good place to start as well. And to give RegenWA a plug too, I guess we try and focus on sort of events and embrace that term regenerative agriculture for those that want to, have a platform to share some of those ideas and practices that they're investigating. So we do have a lot of events that's that farmer to farmer learning and sharing, a lot of those conversations happen in the lunch or the afternoon teas, where people connecting and then hopefully go out and see what other farmers are doing in the space. But then obviously we then try and bring in speakers and connect to the research and science happening on ground here specifically in WA, but extend that out as well. We've got one more question. Where can we access the case studies, Sarah? So I think they're on the Soils for Life website.
Yes.
Maybe you could put a link on the chat.
Yeah, I was going to say there's lots of useful things we talked about today. I'm just mindful of time. We've got 1 minute until the Landcare Network webinar starts and don't want to cut into that. So if you are hoping to jump across, yeah, that's starting really soon. So I will try and wrap up now. But yeah, we might put together some links for all these useful resources we talked about and send it out in a follow-up email. So yeah, thank you so much, Fran and Sarah, for your time today. Really appreciate that. And also big thanks to our comms team and Thomas working behind the scenes to help in the chat if you did want to jump across. So thank you, everyone, and enjoy the next webinar if you're jumping across.
Thanks.
Thank you for the opportunity.